because I'm trying to get going. All right, so problem 47. I talked to you guys yesterday about how to start it. So we said that we're talking about a clock, 15 minutes out of the 60 minutes, so you should have written 15 minutes over 60 minutes. That's for the first problem. What should you have written for the second part?
2 pi r.
Yeah, 2 pi r. And what's the r?
Radius.
6. Okay. And then for the other one, we should have done 25 minutes out of 60 minutes. And then 2 pi times 6. And in the problem, they do not specify if your answer should be exact or approximate. So here you just have to think about the story and if it makes more sense to answer with a pi in it or if it makes more sense to give them a decimal answer. So in the context of the problem, would you make more sense of it if I said that the tip of the hand moved something pi inches or if I said it just moved a decimal number of inches? Decimal. Okay, so we're going to say this is approximately. That's what a squiggly equal sign means. And I'm going to go ahead and type that in my calculator. 15 over 60 times 2 times pi times 6. And we get 9.425. And what are the units? Inches. Should it be inches or inches squared?
Inches squared.
All right, think about it. Just inches because it's a length. I tricked you. All right. And then we're going to go ahead and do the same thing. I'm going to type it in again, but this time I'm going to do 25. Say it again. 12 times 15, maybe, yeah, sounds about right.
That's what I got, because I didn't get multiplied.
Right. That's fine. Alright, if we do the second one, we get 15.708 inches. Okay. Problem 48. Problem 48 is talking about a pendulum swinging at a 20-degree angle each second. So if it said 20 degrees, we're going to do 20 degrees out of 360. Good. And then 2 pi 40. All right, so again, story problem makes more sense to have decimal answers. You have a question? What's up? That's the radius, because if it went all the way around the circle, it would have been double that. It would have been 80 across the circle. Because wherever it's swinging from would be the center. Okay. So we're going to type in 20 over 360 times 2 times pi times 40. And 13.963. And this is inches per second because they were asking us about the rate. It was swinging back and forth, and that's how far it was swinging in 1 second. So 13.963 inches per second. Okay. How do we feel about those problems? In my opinion, the hardest part is knowing if it's a length or an area. Once you know which one it is, you just plug the numbers in. Okay. The other side gets a little bit more confusing because now it's talking about speed. So angular speed is how fast the angle is being made. Linear speed would be how fast the arc length is being made. Does that make sense? Do you guys see how none of them say area speed? So these are both arc length problems because they say linear speed. So if they're saying linear speed, they're saying how fast are you traveling along a length. If they're saying angular speed, that's how fast are you making an angle. Nothing said how fast are we making an area. Okay? So here we're going to be using the arc length formula again. We're going to do two problems, one for angular speed and one for linear speed. So angular speed is just going to be the angle that you're making divided by how long it took to make it. Linear speed is how far it went divided by how long it took to make it. So think about speed in your car, miles per hour. So here our linear speed is going to be centimeters per second. Our angular speed is going to be radians per second. Does that make sense? We're thinking about that? So what is the angle measurement they say is happening? Pi over 3? So we're going to say pi over 3 radians. Yeah. Over, not over 2 pi, because this is radians per second. So we're going to put this over the amount of time, 20 seconds. Okay, pi thirds over 20. I'm going to call that pi over 60. Are we comfortable with how I got that?
Yeah. Oh, yeah.
I combined my denominators basically. Okay. So pi over 60, and this would be radians per second. Radians per second. And that's my angular speed written in exact form. That's it. Yeah, it wasn't as bad as it maybe seemed like it was going to be, as long as you understand how speed is made. So it's some sort of distance divided by time. In this case, the distance we had was an angle. So it's the angle divided by the time it took you to make that angle. Okay? Pi over 60 radians per second. Now, is that a reasonable answer in radians? Pi over 60? Is that how radians are typically written? Yeah, they're usually written like that, right? Like 2 pi thirds, whatever pi in an answer, like in terms of radians, kind of makes sense. We could also do the decimal answer and give that as well, the approximate answer. So I'm going to go ahead and find that. Pi divided by 60. So this could also be written as 0.052 radians per second. I would say in this case, whether or not it's a story problem, both of those answers are pretty good. We're used to exact values. So that's a pretty good answer. Okay. Linear speed is going to be the length that you're going divided by that same 20 seconds. So since the length that is happening is an object that is traveling around a circle, then that means that for us to do our linear speed, we're going to have to find the arc length, because it's not a straight distance, it's a curved distance that we're finding. So we're going to find the arc length divided by 20 seconds. And that's how we're going to find the linear speed.
When you say a pretty good answer, does that mean that
I just think like pi over 60 for radians, most people are pretty comfortable with that. Like pi as a radian answer is pretty good. Most people are a little less comfortable with 0.052 as radians. Most people like the pi better. Divided by 60, a lot of people don't like that, but we can't do much about that. Like most people are more comfortable with like 2 pi thirds, pi halves, pi 6. Those are nice. Pi 60 is not as nice, but better than what we could have had. All right, so here we have arc length divided by 20 seconds. How do I find the arc length for this problem? So we're going to use our formula. So we're going to have something over something times something. Our angle divided by, so we're going to have pi thirds divided by 2 pi. And we know that we're doing that because this problem is in terms of radians. So we're using the portion that is in terms of radians. Pi thirds divided by 2 pi times, what's the rest of the arc length formula? 2 pi r, and in this case that would be 2 pi 5. Okay. So the 2 pi's cancel out, right? We have a divide by 2 pi and a times 2 pi. So we have pi thirds times 5. Pi thirds times 5. How could I write that in exact form? So no calculator. How could I write that in exact form? Yeah, 5 pi thirds. Okay. What are the units on that?
Centimeters.
So centimeters per second. Or that is this problem, if you're talking about centimeters per second, most people are not going to say 5 pi thirds centimeters. In this problem, that as a radian measurement, that makes a lot of sense. Now that we're talking centimeters, that's kind of a weird answer. Nobody really says pi when they're saying centimeters. So I'm going to go ahead and type that in my calculator, and that would be what? 236 centimeters per second. So we got our linear speed, we got our angular speed. Yeah.
So if we did have like 3 centimeters squared, that's would be right though?
Yes, it would be right. It would be dependent. So in this problem, I never specified exact answer or approximate. So technically, both answers would have to be accepted in each situation. So it would just be dependent on what the instructions said. They're both right answers. Yeah. Okay, so same thing in number 50. They're going to ask us about angular speed again. And they're going to ask us about linear speed again. So now we just have to read the problem and see what information we have. So it says an object is traveling around a clock with a radius of 2 meters. So I have r equals 2. In 20 seconds, so we're dealing with the same amount of time that we had in the last problem. In 20 seconds, the object travels 5 meters. So it's still traveling around a circle, and it traveled 5 meters. What did they just give us? No, the radius was 2. So it's traveling around the circle, and it traveled 5 meters. They gave us the arc length. Okay? So I'm going to label this 5 is the arc length. So they told us exactly what it was. We don't have to find the arc length this time because they gave it to us. Okay. What is the angular speed? So they said degrees per second. They don't want radians this time. We want degrees because they told us degrees per second. And what is the linear speed? They want meters per second. So in this particular problem, the linear speed is the easy speed to find because it's just the arc length. It's how far you travel divided by your amount of time. So what do we do for our linear speed? 5 meters divided by 20 seconds. And what do we get? 0.25 or 1/4. We get 1/4 meter per second or 0.25 meter per second. So that one was easy because they gave us that information straight away in the problem. Okay, did they mention an angle anywhere in that problem? No. But they did mention an arc length, and arc length has to have an angle somewhere before you can get that measurement. Okay, so I'm going to write out the arc length formula, which is the degree measure that we have, and this time, since we're in degrees, we're going to divide by 360 times 2 pi, and what's our radius? 2. And what does our arc length equal? 5. So I filled in everything that I knew to the arc length formula, and that means the only thing I don't know is the angle measurement, and so I can solve for that. That's going to be my unknown or my variable in this case. So what could you start to move away from theta? 360. How do you remove a divide by 360? Okay, so we're going to times 360 and times 360. So theta times, are you guys okay with me simplifying this?
Sure.
What would it be? 4 pi? It's 4 pi. So 5 times 360. 1800. Now she's just being difficult. Alright, and then what do we do to get theta all by itself? Divide by 4 pi. So theta equals, does 1800 divided by 4 simplify?
Yeah.
Yes.
900 over 2, which is 450 over 1. So 450 over 1 pi. The pi is on the bottom.
Oh.
And so you have to make sure that you keep it on the bottom. Alright, and our answer was in terms of what unit? Degrees. So 450 over pi degrees. Is that how we write degrees? That is a real weird. So technically it's right, but that's real weird. So let's go ahead and type that in our calculator. 450 divided by pi. 143.239 degrees. That degree answer makes a lot more sense. Yes, it is. All right. We feel better about those?
Kind of, sort of, yes.
So angular speed is, you're just thinking, how far is my angle? How long is my time? For linear speed, we were just thinking, how long is the arc divided by how long is the time? Okay?